Now, class 12 student, today I'm going to give the concept of first order derivative for class 12 student. Now, in this case, today's class or today's video will discuss the formula functions. Okay. Now, next video, I'll start solving numericals. And before doing the numericals, you should have a perfect concept of the formula of derivative as well as the concept of trigonometry of class 11 and the inverse trigonometric formulas. Now, next video only I'm going to start the numerical. This one is the concept, and this concept is very important. Now, today we'll discuss first it formulas. Now I'll discuss first it formulas. Now these formulas are now say derivative of x to the power n is n x to the power n minus 1, d by dx of x is 1, derivative of any constant is 0, derivative of 1 by x is minus 1 by x square, derivative of root x is 1 by 2 root x, derivative of e to the power x is e to the power x, and derivative of e to the power x is e to the power x log e to the base e, and derivative of log x to the base e is 1 by x. These first 8 formulas are discussed today, and some more formulas are coming. That's it. X to the power n means this formula is called variable to the power constant. For this formula, you will get this kind of identities while solving the numericals. Now say dy dx of x square, dy dx of x cubed, dy dx of x to the power 1 by 3, dy dx of x to the power 4 by 5. Now, for this kind of identities that you have to use x to the power n formula, and its formula is n x to the power n minus 1. Suppose if I apply this formula over here, what is the derivative of x square? N is 2. Using this formula, n x to the power n minus 1, that is 2x to the power 1. For this function, this one will be 3x to the power 3 minus 1, that is 3x square. If it is 1/3, then 1 by 3 x to the power 1 by 3 minus 1. Then you have to take LCM. Take 3 LCM, it is minus 2 by 3. Similarly, this one 4 by 5 x to the power 4 by 5 minus 1. In power function also, power function that you have to subtract 1. If you take 5 LCM, it will be 4 minus 5 is minus 1 by 5. These are the applications of x to the power and constant to the power, variable to the power constant. This way we can differentiate. Or if you know the formula perfectly, you can directly these things. No need to do all the steps, directly you can write, but you have to be perfect in the formulas. Now the next formula is dy dx of any function is x. Derivative of any function, if it is x only, then we can write it is equals to 1. Dy dx of any constant is 0. Constant means which are not variable. Constant means which are not variable, like x and y means variable. If it is not variable, the derivative of any constant is 0. These two formula you can derive, you are using this formula only. These two formula can do by this formula, or directly you can remember. And these are the algebraic functions. These are algebraic function of derivative. Now over here, these two functions are over here. This is called exponential function. While differentiate dy dx of e to the power x square is e to the dy dx of e to the power x is e to the power x. But in question, you will get these things in a different form. Maybe you will get dy dx of e to the power 3x, dy dx of e to the power x square, dy dx of e to the power root x. While solving the numerical, we will discuss these things. The exponential e will be e always in the case of derivative. Now a to the power x is another important. A to the power x means this one is, these two formulas, this is variable to the power constant, this is constant to the power variable. Now the practical example of these things are dy dx of, you may get 2 to the power x. 2 to the power x means a to the power x. In this case a is 2. Maybe dy dx of n to the power x, constant to the power variable, dy dx of 10 to the power x. This way you will get the function in this form. Constant to the power variable, constant to the power variable, constant to the power variable. Always think about e to the power x formula, and its formula is e to the power x log e to the base e. If I differentiate this function, then what will get? E to the power x. E to the power x is e to the power x log e to the base. Is 2 to the power x means 2 to the power x log 2 to the base e. This one, n to the power x log n to the base e. If I differentiate this function, this one will be 10 to the power x log 10 to the base e. You can apply this way this formulas. Log x. Now the logarithmic function. Derivative of log x is 1 upon x. It's a direct formula. But while solving the numerical, you may get these things. Derivative of log x square dy dx of log root x. Maybe sometimes trigonometry also that you'll get. Log of like sin x, log of cos x, log of tan x. Okay. Now these are the basic application of log x to the base e. You may get this kind of functions while solving the numericals. Next video I'll discuss numericals, but today we'll discuss the formula only. Now next is the trigonometric form of derivative. Now over here there are 12 formulas, 9 to 20. Now these all formulas are related to the trigonometry and inverse trigonometry. First 6 formula related to trigonometrical ratios, and next 6 formula related to the inverse trigonometric functions. Now say derivative of sin x is cos x, dy dx of cos x is minus sin x, dy dx of tan x is sec square x, dy dx of cosec x is equals to minus cosec x cot x, dy dx of sec x is sec x tan x, dy dx of cot x is minus cosec square x. These are the trigonometrical ratios formula of derivatives. Clear? You have to be perfect in this formula, then only you are able to solve the numericals, and without knowing the formula it's not possible to do the derivatives. Now question 15. Derivative of sin inverse x is 1 by under root 1 minus x square. Derivative of cos inverse, you just say derivative of sin inverse and cos inverse, only the difference is the minus. One is positive, one of these negative. Same way the derivative of tan and cot, tan is positive, cot is negative. Derivative sec and cosec, sec is positive, cosec is negative. There are 12 formulas of trigonometry that you have to be perfectly, that you have to learn these formulas, then only you are able to solve the numericals. And these things are very important for the integral also. The integral is antiderivative. Opposite of derivative is the integral calculus. If you know perfectly, if you learn the formula perfectly, derivatives formula, then the integral, in integral also is easy to learn the formula in integral calculus. Now formula number 21 and 22, it's related to the formula number 21 is related to u into v and u by v. Dy dx of u into v means u dy dx of v plus v dy dx of u, or you can say this is second. First derivative of second plus second derivative of first, or u upon v, you can learn this way. Second, u upon v is v square, v dy dx of u minus u dy dx of v, or second square, second derivative of first minus first derivative of second. Now where you will use this formulas? Now say the 21. Suppose in one particular function, if there are more than one variable, let us suppose the variables are, suppose dy dx of x into e to the power x. X into e to the power x means there are two different functions. One is x, another is e to the power x. So randomly you can consider this e to the power x is u, this one is v, or first one is u, second one is v. I'll consider this is u and this one is v. Now I'll apply this formula. U dy dx of v plus v dy dx of v. I've already given you formulas. Now say the dy dx of e to the power x is e to the power x plus e to the power x into derivative of x is 1. You can take x common, e to the power x common, it will be x plus 1. It's the same thing we can apply this way also. Let's suppose if it is in terms of x over e to the power x means which formula? The formula number 22 that you have to apply. U upon v. V in this case is e to the power x, u is x. I'll apply this formula. V square v dy dx of minus u dy dx of v. Now e to the power x into derivative of x is 1 minus x derivative to the power x is e to the power x over e to the power x whole square, or we can take e to the power x common. 1 minus x over e to the power x whole square. We can cancel this too. The final result will be 1 minus x over e to the power x. This much of numerical you have done in class 11 also, but I'm just doing the revision of class 11, a little bit of revision. Now from next video I'm going to start the numerical application of formula in numericals, and the second video is very important, but I'm going to upload the second video on Monday. But till Monday you have time, today and tomorrow you have to learn all the formulas, then only you'll understand the concept of numericals. Thank you.